In 6 months, OpenAI says, it'll have an AI system that can do research on its own for days at a time. So, not for writing code, not for answering questions, but for conducting sustained independent scientific investigation, the kind of thing that currently requires a postdoc, a whiteboard, and a week of uninterrupted thinking. Now, Andre Karpathy recently released something similar to this, open sourced it. OpenAI is looking like they're finding a gap here or a niche here that they'd like to fill on the proprietary side. So they said September. They put a month on it. And on the same day they said that, they also brought the plumbing. So let me unpack what actually happened because two announcements landed from OpenAI yesterday that sound like separate news, but they're really a single move. First, Jacob Pachaki, OpenAI's chief scientist, told MIT Technology Review that the company is building toward what he calls an autonomous AI research intern by September, a system that works unsupervised for days on problems that currently require human researchers. The longer vision, targeted for 2028, is a full multi-agent research system tackling problems too large or too complex for humans to cope with across math, physics, biology, chemistry, and even policy. Second, OpenAI acquired Astral. You probably haven't heard of them, and that's the point. Astral makes the tools that Python developers use to manage their code environments. UV, Rough, TY. They're downloaded hundreds of millions of times a month. And Astral is being folded directly into OpenAI's Codex division. Now, why does a company chasing autonomous research buy a developer tools company at the same time? Because as an AI researcher that can think but can't manage its own software environment is like a brilliant scientist who can't open the lab door. Astral's tools are that door. They're the infrastructure that lets software projects run, get tested, stay organized. By bringing them inside Codex, OpenAI's coding platform, then OpenAI is making its AI systems native to the environment they operate in, not just visitors to it, and definitely able to open the door. So Pachaki was explicit about the lineage. He called Codex, which already has over 2 million weekly active users, including yours truly, as well as Claude Code and many others, but a very early version of the AI researcher. The progression he described is one of duration. GPT-3 could sustain coherent work for a few paragraphs. GPT-4 could hold together for pages. The September target is an AI that stays on task for days. And again, this isn't record breaking. We've had AI that have been able to stay on task for days building towards a single task, but this is specifically for research. So this is not that they're able to do this because they trained it for endurance or anything like that, but because, as Pachaki put it, improvements in general capability naturally extend how long these systems can maintain independent investigation. Doug Downey at the Allen Institute for AI confirmed the broader momentum as well. He said, the fact that you can delegate quite substantial coding tasks to tools like Codex is incredibly impressive, and it raises the question, can we do similar things outside coding in broader areas like science? So think about what that means. Right now, the bottleneck in most scientific fields isn't ideas, it's person hours, it's time. There are more promising research directions than there are trained researchers to pursue them. If what Pachaki describes works, even partially, that constraint will flip. The bottleneck will stop being who's available to investigate this, but it will become what questions are worth asking. And that is a fundamentally different kind of science. Narc tracking here really matters. The Century Report documented Uber's AI agent making 1,800 code changes per week back on March 18th. Google disclosed that AI writes the majority of its code. On March 7th, Claude found 22 high-severity Firefox vulnerabilities in just 14 days, and GPT 5.4 solved a math problem that a researcher had spent 20 years constructing. What Pachaki described yesterday is the intention to make that kind of sustained autonomous work routine and to scale it computationally. His phrase was a whole research lab in a data center. Now, Anthropic made a similar infrastructure move in November. They acquired Bun, the JavaScript runtime, and integrated it into their own coding platform. The pattern across both of these frontier labs then is the same. Absorb the computational plumbing, make the AI native to the development environment, extend the duration of autonomous work. Charlie Marsh, Astral's founder, committed to keeping the tools open source, and that matters because the ecosystem that millions of developers depend on won't just disappear, and that's essential. Instead, it just gets extremely powerful with its new tenant. So let's shift to a new story here. While all that was happening inside premier AI labs, the physical world also crossed a threshold that deserves its own moment here. Global installed wind and solar capacity passed 4 terawatts in 2025. The world added 814 gigawatts of new capacity in a single year, a 17% increase over the previous record. Solar alone contributed 647 of those gigawatts. Wind also rebounded sharply, up 47% year over year. Let me make that concrete. The generation capacity installed in 2025 alone can produce roughly 1,046 terawatt hours of electricity annually. That's enough to displace more than 1/7 of all the gas-fired power generation on Earth in 1 year of building. And there's a geopolitical dimension that's immediate as well, with the Iran conflict driving energy price volatility. Ember, the energy think tank that published these numbers, calculates that all installed wind and solar worldwide has avoided approximately $40 billion in potential fuel costs since the escalation began. Kingsmill Bond, Ember's energy strategist, said it directly. Solar, wind, and batteries give importers a genuine path to energy security, one that is cheaper, faster to deploy, and doesn't come with geopolitical strings attached. Now, here's where the energy story and the intelligence story lock together. Yesterday, Tesla and LG announced a $4.3 billion battery manufacturing plant in Michigan. We covered this, and that's going to be opening in 2027. It'll produce cells for Tesla's Megapack 3, that's utility scale grid storage. This follows GM and LG retooling their Tennessee plant for EV cells to grid storage, which we covered just the day before. Two of the world's largest battery partnerships within 48 hours, both pivoting manufacturing towards stationary storage. This is not a coincidence. This is demand pulling capital toward where the growth actually is. And here's the feedback loop nobody talks about enough. The batteries enable the renewable generation. The renewable generation powers the data centers. The data centers train the models. The models accelerate material science for the next generation of batteries. Each layer feeds the next. And of course, energy is going to change over time here. It may be that we are looking at a completely different energy stack here pretty soon, but for now, that's where things look like they're headed. The energy substrate and the intelligence infrastructure are not parallel buildouts. They're a single reinforcing system now being constructed at terawatt scale. All right, let's shift away to another story here about the internet in general. Cloudflare CEO Matthew Prince said something at SXSW yesterday that I think people heard as a statistic, but it should have heard as a structural shift. He projected that AI bot traffic will exceed human internet traffic by 2027. Cloudflare handles traffic for 1/5 of all websites, so this isn't speculation from the outside. This is the company that watches the packets flow, and their CEO is saying this. People have speculated about this for a while. When will AI agents start to surpass human traffic on the internet? But here's the mechanic. When you shop for something online, you might visit 5 websites. An AI agent doing the same tasks visits 5,000. Every agent task generates real load on servers, real bandwidth, real energy consumption. And unlike the COVID traffic surge, which spiked and then leveled off, agents-driven traffic shows no signs of plateauing. It's compounding. Prince described the need for what he called sandboxes, isolated computing environments spun up specifically for an agent's tasks and then destroyed when it's done, and projected millions of these being created every second in real time. The physical internet, the actual cables and servers and cooling systems, they were built for human browsing patterns. That needs to be repurposed for something entirely different. And this connects to the Meta Rogue Agent incident the Century Report covered over the last couple of days. When an AI agent autonomously posted technical advice inside Meta and triggered a near highest severity security incident, exposing sensitive data for 2 hours, the failure wasn't that the agent was broken. The failure was that the internet, the internal network, the permission structures were all designed for a world where the entities posting things are human. An agent that visits 1,000 websites to answer one question doesn't just use more bandwidth. It makes decisions at every stop about what to access, what to share, what to act on. And the governance architecture for those decisions, it's not here yet. It's being constructed incident by incident, like we talked about yesterday, exactly the way Meta is learning through things going wrong. All right, separate item here. This brings us to Moxie Marlinspike. If you use WhatsApp or iMessage or Signal, the encryption protecting your conversations was built on protocols that this person created. And yesterday he announced that his company, Confer, will integrate its privacy technology into Meta AI. making this the first serious attempt to bring end-to-end encryption to AI conversations at the scale of billions of users. Very interesting timing, right? His framing was blunt. As LLMs continue to be able to do more, we should expect even more data to flow into them. Right now, none of that data is private. So the technical challenge here is genuinely difficult. End-to-end encryption for messaging means only the sender and the recipient can read the message. But with AI, the system itself needs to read your message to respond to it. So encryption has to work differently, protecting the data from the platform operator while still letting the model process it. That's the problem Confer has been working on. And I think it's been a problem that's been in the back of many of our minds for a very long time here. And this timing is pointed. Wired reported separately yesterday that OpenAI's planned adult mode for ChatGPT would create what they are calling an intimate surveillance surface, where sexual preferences, fantasies, and deeply personal conversations are logged and stored. Even temporary chats can be retained for up to 30 days per their policy. Meanwhile, Google just announced that Fitbit's AI coach will read users' medical records. So the surface area of what AI systems know about you is expanding in every direction simultaneously. And we're still building out exactly what that's going to look like. NYU cryptographer Mallory Nodal identified the real stakes here. Encrypted AI would mean Meta would not be able to access the AI chat data for training. You can talk to the model and have the advantage of that power with the model, and it would not be sent to Meta for training. This is a structural renegotiation of the relationship between you, the AI system, and the company that operates it. And it's being proposed by the person who already won that negotiation once for messaging. So whether he can win it again for AI will determine whether the most intimate technology humans have ever used operates behind closed doors or glass walls. All right, let's shift again to another story. This is about a virus that unlocks the immune system. And this is a story I keep thinking about today. Glioblastoma, the most lethal brain cancer. The standard of care for it hasn't changed in 20 years. Immunotherapy has transformed treatment for melanoma, lung cancer, kidney cancer, but glioblastoma has resisted everything. And the reason is, of course, architectural. The tumor creates an environment that is immunologically cold. It actively excludes T cells, the immune cells your body uses to kill cancer. The soldiers are there, but the tumor won't let them in. Yesterday, researchers at Mass General Brigham and Dana-Farber published a phase 1 trial in Cell showing that a single injection of a genetically modified herpes virus changed that. And here's how. The virus was engineered to replicate only inside glioblastoma cells. It infects a cancer cell, kills it, and produces copies that spread to neighboring cancer cells. But the killing isn't the breakthrough. What happens next is the dying cancer cells, destroyed by a virus the immune system recognizes, trigger an immune alarm. T cells flood into the tumor, a place that they were previously locked out of, and they stay active. They persist. In 41 patients with recurrent glioblastoma, the treatment was associated with longer survival compared to historical outcomes. Researchers mapped the spatial position of immune cells within the tumor in extraordinary detail and found that patients whose cytotoxic T cells were located physically closer to dying tumor cells survived longer. The therapy didn't just deliver a weapon, it converted the tumor from a place where immune cells couldn't go into a place where they could fight. Senior author Kai Wucherp-Pfennig said, "It's now feasible to bring these critical immune cells into glioblastoma." If you know someone with this diagnosis, that sentence is critical to you because it means the door that was locked for 20 years just opened. Not all the way yet, of course, but enough that combination approaches, layering other immunotherapies on top of this, now have a path that did not exist before. The immune system was always capable, but it just couldn't get there, and now it has a path. All right, let's talk about what shipped. Several things worth flagging from what shipped yesterday. Cursor released Composer 2, their own in-house coding model. It's scoring at frontier-level coding benchmarks, roughly on par with Claude Opus 4.6 at 86% cheaper than their previous model. That's a code editor building its own AI from scratch and competing with the big labs. Anthropic shipped Claude Code channels. You can now control a Claude Code session remotely through Telegram or Discord, meaning you don't need to be at your computer to direct the AI coding agent, nor do you need to use the app. NVIDIA released Nematron Cascade 2, a 30 billion parameter model with only 3 billion active at any time, achieving gold medal level performance on the International Math Olympiad, the International Olympiad in Informatics, and the ICPC World Finals. Open weights, 20 times fewer parameters than frontier competitors reaching the same tier. And Cognition launched multi-agent Devon, where one Devon autonomously decomposes a large task and delegates subtasks to parallel Devon instances, each running in its own isolated environment. That's an AI agent that manages a team of AI agents. So the architecture that Pachocki described for research has been arriving for quite some time now for code, and it's only getting stronger. Here's what sits with me from yesterday. OpenAI put a month on the calendar, September. That's when they expect a system of AI can conduct independent research for days at a time. In the same 24-hour period, the world documented that it built enough new solar and wind energy capacity in a single year to displace 1/7 of global gas power. And a virus injected into the deadliest brain tumor proved that it could open a door the immune system had been standing outside for 2 decades. 3 different domains, 3 locked doors. And in each case, the breakthrough wasn't adding something the system lacked, it was removing the barrier that kept the existing capacity from reaching where it needed to go. The AI needs the development environment. The renewables need the storage. The immune cells need access to the tumor. Yesterday, all 3 of those barriers got thinner. Very soon, watch what happens when Codex's 2 million weekly users get Astral's tools baked in, because it's far more than a product update. That is the moment that an AI coding agent stops needing a human to set up its workspace. And what comes after that is what Pachocki described, a system that doesn't just write code, but asks questions, tests hypotheses, and works on all that while you sleep. We'll see you tomorrow.